Hello. So today's lesson is growth and decay on an application of the geometric sequence formula. So first I'm going to give you a bunch of questions that you're going to be familiar with, but I don't want you to answer them. I just want you to read them. So you're selling tickets to your party, and the first week you sold 12 tickets, and each week you saw 5 more than the previous week. So the questions might be, how many tickets will you sell in the 9th week? How many tickets in total will you have sold by the 15th week? And if tickets cost 70 taka, how many weeks will it take you to make 5,000 taka? You're familiar with these questions. But let's take a look at another question, a growth and decay question. A population of 500 elephants grows at a yearly rate of 7%. How many elephants will there be after 10 years? So I want you to compare and contrast the questions about the elephants and tickets. So we see they're both questions about increasing values, but they increase in different ways. The question about the tickets has arithmetic growth. The change is a rate by a common difference. The elephants have geometric growth. The rate is a change by percentage. I think this is going by itself. So for the elephant question, we need a new formula. Y equals A times B to the T, right? So the A will be the initial or the original amount. Y is the final amount. B is going to be the growth factor, and I'd like you to see B as equaling 1 plus or minus R, where R is the rate of change. And T is going to represent time, how long the growth or decay lasts. Let's return to the elephant question. Initially, there's 500 elephants. The rate is 7%, which we will write as 7 over 100, or 0.07. B, the growth rate will be 1 plus 0.07, or 1.07. And T, the time will be 10 years. Oh, no, that's not good. Sorry. After 10 years, there will be 500 times 1.07 times to the 10th power, which equals 983.6 or 984 elephants. Words to look for which represent an increase. Growth appreciates appreciation. Words to look for which represent a decrease. Decay depreciates depreciation. A $250,000 house appreciates at a rate of 4% per year. First question, how much is the house worth after 5 years? And how long until the house doubles in value? Well, initially the house is worth $250,000. The rate, which is 4%, which we will write as 4 over 100, or 0.04. Because the rate is appreciating, the growth rate will be 1 plus 0.04. Sorry. The growth rate will be 1 plus 0.04, or 1.04. The time will be 5 years. Therefore, the answer after 5 years, do you think you do it by yourself? What's the answer? 250,000 times 1.04 to the fifth, or $304,163. The next question, how long until the house doubles in value? The original amount was 250,000, but this time the final amount is 500,000. We have that other variable. The rate is still 4%, so the growth rate is still 1 plus 0.04, or 1.04. But now t is the unknown variable. So the idea is you're going to set up an equation. Can you set up an equation? The equation is 500,000 equals 250,000 times 1.04 to the t power. I'm going to use Desmos to solve this, and the answer is 17.7 years. Watch this video on how to use NSolver in your GDC. Next question. Question number 2. A car depreciates in value at a rate of 5.9% per annum. When you see the word per annum, that's the same thing as per year, and you also might see it written as PA. How much is the car worth after 8 years? Well, when you think about that, get the variables. Take any variables you know from the question and see if you can put it together in the formula. So we know the initial amount, or you might want to pause the video. The initial amount is 6,000. Because of the rate of change, rate is 5.9%, it's depreciating, B is going to be 1 minus 0.0459. The time is 8 years. After 8 years, the car is worth 6,000 times, open parentheses, 1 minus 0.059 to the 8th power, which is $3,688.66. Next question. How long before the car is worth only $1,000? Well, we have our initial, but now we have our final amount. The original amount is 6,000. The final amount is 1,000. The rate is still 5.9%, and so the depreciation rate is still 1 minus 0.059, and t is the unknown variable. Can you put it together in the formula or create an equation? Yeah. Sorry. Sorry. Can you come up with the formula, an equation, and use NSolver or Desmos to solve? Let's see. 1,000 equals 6,000 times 1 minus 0.059t. The answer is 29.5 years. The last question, how much did the car depreciate after 8 years? It's just the difference between the beginning and the end. 6,000 minus 3,688.66 equals 2,311 and $34. So complete the problems on the document and the online assignments. Whoops, sorry.